Peace. Love me, say that you love me. Damn, son! Wow. We kick at the light, with the light, for the blackout, blackout, with the lights, for the blackout, blackout. Hey everyone, this is my quick Sunday, and today we're going to go real big, real huge, and actually galactic, as we're going to talk about the dimensions of the universe and also the largest objects, celestial bodies, and structures. So if you want to get your mind blown, stay here and buckle up. So in order to actually feel the size of this topic, we need to talk about the difference between 1,000 and a million, and a million to a billion. Because we're saying these numbers, but we don't feel how huge of a jump we've got from 1,000 till a million. The best way to show is in years. So if the equivalent of 1,000 is 10 years for us, then if we count that into a million, that will be 10,000 years. So you know guys, a decade is not that long of a time. We've just started one. But anyway, so if the equivalent of 1,000 is 10 years for us, then the same number in a million is 10,000 years. 10,000 years. The same jump from a million to a billion. And it could be like from the ages 2010 to 2020 compared to the settlement of mankind to the development of writing. It's an incredibly huge difference. Moreover, we've got to cover some basic facts. We can count the sizes of the universe in different shapes. We can do it in case of length, mass, and also volume. For example, we can take Jupiter as a sort of big planet, but its mass gonna be small. Or we can take a black hole, which has a relatively tiny volume, but its mass is never seen before. Also, we are gonna use the term light year. This is the distance light travels in 1 year. And if we count that into kilometers, it's around 9.4607 times 10 to the power of 12. And now we can start from our little beloved solar system and actually Earth. Earth has an equatorial radius around 12,756 kilometers, and the polar radius is pretty similar to it. Its volume is around 1.08 times 10 to the power of 12, and of course in cubic kilometers. And its mass is around 5.792 times by 10 to the power of 24. So we can say Earth itself is huge, but not even close to be the biggest planet even in the solar system. One little correction. So the further we go from Earth, the less exact the calculations are thanks to scientific limitations. But apart from this, for example, Neptune or Uranus are bigger than Earth. Also, Saturn is in this category, and it's actually 763 times bigger in case of volume, which is crazy, especially if we see that the mass of Saturn is only 95 times bigger than the Earth mass. And these numbers are already crazy, but still not the biggest planet we found so far. If we generously multiply Jupiter's volume by 1.8, we can get TRES-4b, which is in fact the largest planet we found, and we could fit in 2,340 Earths in the interior of this crazy planet. Our next stop is stars. Of course, we have a star in the middle of our solar system, so-called the Sun. And this burning object adds up 99.8% of the mass of the solar system. Yeah, we are in the 0.2% Britishity, but that's that. Also, if we had the urge to fill the Sun up with Earths, we could do it with one million Earths. However, our star, the Sun, is still around a general size of a star. The biggest one found so far, called Scuti, is 1,700 times bigger than the Sun. And in theory, we could fit in 1.7 billion, and yes, billion Earths in the interior of this burning star. And now we are going to go real dark. Black holes are mysterious for us, but we in fact know how their mass is unique in the universe. They are created as a result of collapsing massive stars, which already expects how they will have a huge mass. The biggest black hole found so far is TON 618, which has a solar mass of 66 billion. A solar mass is around 2 times 10 to the power 13 kilograms, which are used to actually measure these incredibly huge objects like black holes. However, I have to highlight how there is still a contradiction between scientists that what is the best method to count black holes. Moreover, they're still debating on which is the actually biggest black hole found so far. Other sources say it's about 85, which has 40 billion times of the mass of the Sun. But let's not stick with black holes and move on to galaxies. We pretty know that we live in one, which is known as the Milky Way. The Milky Way has a diameter of 130,000 light years, which is actually the third or actually second largest one in the local group. The local group is the group of galaxies which in the Milky Way exists. Actually, the biggest one, called Andromeda, is just 2 times bigger than us. But all these galaxies are just children compared to the biggest one found, that is IC 1101. It has a diameter of 5.5 million light years, which is approximately 50 times bigger than ours. Moreover, if we count this into kilometers, we can get this number. Before we move on to actually structures, let's talk about the biggest object, single object found so far, which is SPT 234956. These namings are just madness. But anyway, this object is a result of 14 galaxies crashing together, and it resulted 10 trillion times of the mass of the Sun, which is... The group of galaxies can be classified into superclusters. The Milky Way is part of the local group. The local group is part of the Virgo supercluster, and then the Lanaké supercluster, which is 520 million light years across. But we are not done yet, because the biggest, or actually longest, known galactic collection is Shapley supercluster, which is 10 billion trillion times of the mass of the Sun. So these superclusters often found in actually voids. And what if I say to you that we are in the middle of nothing? Because our supercluster is in the middle of a void. These voids are sort of places in the universe where there is low to zero amount of light, galaxies and stars. And these voids can actually grow incredibly big. The biggest one found so far is 1.8 billion light years across, called supervoid Eridanus. And now just think the previously mentioned biggest galaxy, IC 1101. It has 5.5 million light years in diameter, while this has 1.8 billion. This jump between million to a billion. And now just consider the thing I was explaining to you in the beginning of the video, which consists the jump from 1,000,000 to 1,000,000,000. And if we put this into context, wow, these voids are unimaginably huge, and scientists are arguing how they can exist. In spite of covering all these incredibly and unimaginably huge numbers, the largest, the longest, the biggest object or structure is still up, which is Hercules Corona Borealis Great Wall. And this is what we know as the longest, or just the biggest, the most enormous object in the universe, which has a diameter of 10 billion light years across. This is 5 times of the largest void I've just mentioned, and actually 1/9 of the whole observable universe. We have one last thing that we have to talk about, which is the whole universe, the dimensions of the universe. The oldest light we could reach is actually coming from 13.8 billion light years, and the whole observable universe is around 93 billion light years across. And the observable universe is the universe we can examine, but this is not the whole universe. And probably we will never be able to examine the whole universe, as the universe in fact is expanding, and by the time light would reach the borders of the universe, the borders have already shifted, because this increasement of the universe is actually faster than the speed of light. We don't know if the universe is finite or infinite, and we don't have enough proof for either. However, the only thing we can surely say about the dimensions of the universe is that the human mind is not capable of understanding it completely. However, we have the opportunity to study and examine a lot. And if you love this way of studying, then be sure to subscribe and hit us a like. Also, you can check the bell icon for notifications, and a share would be galactic, guys. Also, you can follow us on Facebook, Instagram, TikTok. Thank you for the attention, and see ya!